Okay, our second example is a little more complicated. We're going to roll 2 die. All right, and let's just think about our sample space again. We could get a 1 on the first die and a 1 on the second. We could get a 1 on the first and a 2 on the second. A 1 on the first and a 3 on the second. A 1 and a 4, a 1 and a 5, and a 1 and a 6. Now that's everything where we would have a 1 on the first die. So let's just change that first die. We could have a 2 and a 1, a 2 and a 2, a 2 and a 3, a 2 and a 4, and so on, all the way up to the 6 dots that are on that second die. All right, now again, we could have something else on the first die. We could have a 3 on the first die, and you kind of see the systematic way I'm doing this, so I get all of them. 3 and 3, 3 and 4, and of course we could get a 4 on the first die. We're going to go all the way up to 6. So this is a fairly large sample space. 4, 5, and 4, 6. And of course we can get a 5 on our first die. Still rotating what we get on our second die all the way across. And then lastly, we could get a 6 on our first die. So there's our entire sample space. Now, from that sample space, we have to construct a probability distribution. And we're looking at the sum of what's on the die. All right, so let's notice the smallest sum, the smallest when we add the two numbers that are on the die together is going to be 2, because the 1, 1 is going to add to 2. The largest, if we look down at the bottom, we're going to get 6 plus 6, it's going to be 12. So we want our probability distribution to go from 2 to 12. All right, so let me go ahead and insert a table for it. And it's going to be 2 columns. And then 2 through 12, I'm thinking I'm going to need 11 rows. Hope that's right. All right, and we'll go ahead and add that. All right, so I'm going to let my first column be x. It's going to be the sum of the 2 die added together, and then we'll have the probability of x over here. Okay, so we said the smallest sum we can get is 2. And let's notice that there's only one of our possibilities up above that adds to 2. That's the 1 and the 1. So there's 1, and there's 36 possibilities here. That's 1 out of 36. All right, or if we wanted to, we could change 1 out of 36 into a decimal. Now, let's see how many add up to 3. Well, the 2 and the 1 adds to 3, and the 1 and the 2 adds to 3. Diagonally, we can see those 2. So there's only 2 of them out of 36. Now, again, we could reduce 2 out of 36 or change it into a decimal. But I'm going to keep it there so we can see that everything is going to add up to 1 when we're done. All right, now let's look at those that add to 4. Well, 3 plus 1 adds to 4. 2 plus 2 adds to 4. And 1 plus 3. So notice this whole diagonal right here. All 3 of those add to 4. So there's 3 of those out of 36. All right, and let's see how many add to 5. If we go to the next diagonal, notice 4 and 1, 3 and 2, 2 and 3, and 1 and 4. That's 4 of them out of 36. All right, now let's see how many of them add to 6. All right, so again, next diagonal, 5 and 1, 4 and 2, 3 and 3, 2 and 4, and 1 and 5. That's 5 of them out of 36. You can see this nice pattern developing. All right, and let's see how many of them add to 7. 6 and 1, 5 and 2, 4 and 3, 3 and 4, 2 and 5, 1 and 6. So there are 6 of those out of 36. All right, let's see how many add to 8. Well, let's see, we'll have 6 and 2, 5 and 3, 4 and 4, 3 and 5, and 2 and 6. That's 5 of them out of the 36. All right, and then how many of them add to 9? Well, if we go over to the next diagonal, we'll have 6 and 3, 5 and 4, 4 and 5, and 3 and 6. 4 of them out of 36. And now we want those that add to 10. Well, next diagonal over, 6 and 4, 5 and 5, and 4 and 6. There are 3 of them out of 36. And then 11. Well, 6 and 5, and 5 and 6, so there's 2 of them out of 36. And it looks like I had one too few columns, or rather rows. So let's see if I can just insert one more row. Insert row below. Okay, kind of hard to see in my screen thing here. All right, so we'll have 12. Let's see if I can't just, there we go. And if we look, there's only 6 and 6 that gives us 12, so that's 1 out of 36. And if we add these up, 1 and 2 is 3, plus this 3 is 6, 10, 15, 21, 26, 30, 33, 35, 36 out of 36, it adds to 1, which will always be the case for our probability distribution. All right, so that was the first part of our question. We had to find the probability for each one of these. So now the second thing we wanted to find was the probability, that x is greater than or equal to 9. Now the easiest thing for us to do is, here's the 9 in our probability distribution right there. It had a probability of 4 out of 36, and everything that's greater than or equal to 9 will be the 10, 11, and 12. So let's add up from the 9 all the way down to the 12. So 4 out of 36, 3 out of 36, 2 out of 36, and 1 out of 36. So let's see, that's 7, 9, 10 out of 36 is the probability that our die add up to greater than 9. And we can, of course, reduce that or change it into a decimal, either way. All right, now let's look at the last probability we need to define, was that x is even. So 2 is an even sum, 4 is an even sum, 6 is an even sum, 8, 10, and 12. So we want to add up the probabilities that go with each of these. So 1 out of 36 and 3 out of 36 will be 4 out of 36. And then the 6 is 5, so that's going to be 9 out of 36. And then the 8 is 5, so that's going to be 14 out of 36. And the 10 is 3 out of 36, so that'll be 17 out of 36. And then lastly, the 12, 18 out of 36. So the probability that x is even is going to be 18 out of 36, or half of them, which makes perfect sense.